right, we're in Chapter 14, Quiz B. Let's take a look at the prompt. A new clothing store advertises that during its grand opening, every customer that enters the store can throw a bouncy rubber cube onto a table that has squares labeled with discount amounts. The table is divided into 10 regions. 5 regions award a 10% discount. 2 regions award a 20% discount. 2 regions award a 30% discount. And the remaining region awards a 50% discount. Taking a look at question 1. What is the probability that a customer gets more than a 20% discount? Well, that's the probability that he gets a 30 or a 50% discount. We know that those events are mutually exclusive. They have no elements in common. Therefore, we can just add the individual probabilities. So the individual probabilities for the probability of 30% discount would be 2 out of 10, plus the probability of a 50% discount, which would be 1 out of 10. So the probability that a customer gets more than a 20% discount should be 2 out of 10 plus 1 out of 10, which would be 3/10 or 30%. And again, we know the OR is represented by the union symbol. And when the events are mutually exclusive, we can just add the individual probabilities. Taking a look at question 2. What is the probability that a customer gets less than a 20% discount? Well, if they're getting less than a 20% discount, then they're getting a 10% discount. And in the prompt, we know that there were 5 10% discounts on the table. And we can see them right here. 1, 2, 3, 4, 5. So the probability that a customer gets less than a 20% discount is the same as the probability of getting a 10% discount, which would be 5 out of 10 or 1/2. Question number 3. What is the probability that the first 2 customers both get a 50% discount? Well, these events are independent of each other. The discount the first person gets has no effect on the discount the second person gets. So we want the first customer and the second customer to get a 50% discount. We know and means multiply. We also know because the events are independent, we just can multiply the individual probabilities. So the probability that the first customer gets a 50% discount is 1 out of 10, and the probability that the second customer gets a 50% discount is 1 out of 10. So the probability that the first 2 customers get a 50% discount would be 1 out of 10 times 1 out of 10, which is 1 out of 100, or 1%. Question number 4. What is the probability that none of the first 3 customers gets more than a 30% discount? There is only one discount larger than 30%. That is a 50% discount. The probability of getting a 50% discount is 1 out of 10. So the probability of getting no more than a 30% discount would be 9 out of 10. And we can clearly see that there are 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 regions that would satisfy no more than a 30% discount. So the probability that a single customer gets no more than a 30% discount is 9 out of 10. Well, what's the probability that none of the first 3 customers gets more than a 30% discount? That's the probability that the first customer gets no more than a 30% discount, and the probability that the second customer gets no more than a 30% discount, and the probability that the third customer gets no more than a 30% discount. Well, we know the probability of getting no more than a 30% discount is 9/10. We know that these events are independent of each other. So therefore, we can just multiply the individual probabilities. So the probability that 3 customers in a row get no more than a 30% discount is 0.9 times 0.9 times 0.9, which is 72.9%.